reminder, so we don't have class on Thursday. So I just posted lab 7. We will cover what lab 7. We'll talk about lab 7 shortly. And so now is week number 11. We only have 3 or 4 weeks to go. Then you need to start thinking about what you want to do for the final project. We're going to cover a lot more geospatial content in the next couple of weeks. So for the class today, we're going to talk about how to add base map, how to add vector data, how you display vector data on the map, GeoJSON, swap file, GeoPandas, data frame, something like that. And so labs 7 here. Let's quickly go through this one. So lab 7 looks a lot intimidating, but it's only just a couple functions. And so we cover some blows, for example, add base map, add GeoJSON. We might not have time to cover add swap file or add vector, but it should be pretty much similar. If you know how to do one, you should be able to do something similar for other vector data types. We'll go through examples today. And what else? Any questions about lab 6 is due today, right? By the end of today? Oh, tomorrow, sorry. Tomorrow. If you need more time, let me know. Okay, I'm flexible. So lab 7 is due next Wednesday. Okay, so you have 8 days to finish that. Again, if you have any questions, send email to the list. If you have any problem, try to start early. Alright, so let's get started. And today we'll have something fun. It's basically how to add base map and how to display vector data on the map. Then next week we'll probably talk about how to display raster data, right? So you are dealing with geospatial data. If you have used desktop, you know how to like open the data using ArcGIS or QGIS. But how to actually do the programming, actually how you can actually read the data and then display on the map. So this is something we're going to cover today. But first we go through how to add base maps. And last week we already have the the main module, and let's quickly go through this one here. So this is what we let me see here. Let me get our master. Did I already add that? Let me make a copy. I think I just make some examples, so I want to start from scratch, so I don't want to use the one that we already have. So let me copy here, and let me move it. Okay, so this is what we have last time. And let me open the notebooks just to show you what we have. So IPy leaflet. Let me clear all the outputs. So basically last week we created a module and then we initialize. So now you can actually use your module to create an interactive map. So let's do it one more time. Import GOS demo. Okay, and then m equal to GOS demo.map. Then display the map. Right. So this is basically a pretty basic one. There's nothing fancy. And if you use DivMap, you probably noticed that I add a lot of components. For example, the full screen control, the layers control, something like that. So we're gonna quickly go through how you can actually customize, because this is not very useful, right? It's only the base map. So you need to load the data, vector data, raster data, but you need to also have some control on the map to turn the layer on and off, for example. So how do we actually add that? By default, so that when user create this map, they have the layer control showing up on the map, so that you don't have to add that manually. Okay, so if you are familiar with ipyleaflet, again, you are always welcome to go. Yes.
In my next my package name.py, I do import ipyleaflet and it doesn't recognize the package.
Oh, so they basically when you mean here you import the ipyleaflet?
Yeah.
So if it is not recognized, you lower right corner here, if you see my mouse here, make sure that the environment is the one where you have ipyleaflet installed. If not, you just pip install. So open Anaconda prompt and then just pip install. You should be able to find it. Because we already did it last time, it might be just the environment thing. So make sure that you select the one and then install it. You should be good to go. So here, next we're going to just show you, if you can read the documentation, you can find a lot of examples in here. So GitHub Copilot can also help you do that, but I'm just going to quickly show you if you want to read through the documentation. It's under the controls. What we're going to add here is called this one, layers control. So layers control means it's going to showing up here, upper right corner, and you're welcome to look at the example. Pretty simple, right? ipyleaflet and then layers control. You can customize the position where you want to show it up. So in ipyleaflet, there are 4 corners: top left, top right, bottom left, bottom right. So those are the 4 corners you can customize where you want to add the widget. Essentially, it's just one line of code. Okay. First, let me show you how you can add a function actually to add the layers control. So it should be pretty straightforward. You can go to go to your map class. So always remember, we are going to add the function to the map class. So don't add a function like indented to the left. It does not belong to the map class. If you want to add anything to the map class, it needs to be indented here. You should need to have tab, df, something like that. I can scroll down to the end here and then just type df. So this is where you can choose the name. Okay, I don't know how it figured out. Add layers control. I don't even it lose my mind, it looks like. So add layers control, perfect. Okay, I don't even have to write anything. Take a look at here, ipyleaflet layers control, and then layers control, and then add control. But once you can add here, we can actually add a position. So rather than have this one, I can specify the position. Otherwise, by default, you'll be, I think, top left corner. Maybe let me just Control S to take a look. So add layers control. Always remember, if you add a function or message to a class, you need to have self at the beginning. Otherwise, it's not going to work. So self means you are indicating you are doing something to that object, to that class. And KWARD is basically the keywords argument. You accept like anything. Then you create the layers control, add the layer control. So now if we come back to here, restart the kernel, and then run the source code, right? With that, now we can m.add, okay, layers control, parentheses, run, oops, map.add layers. What happened? Yeah, it should work. Let me restart again. Sometimes it takes a while to propagate it. Okay, done. Take a look. Now it's here. So add layers control. It's pretty simple. But usually, I would love to go to the top right corner, so you can customize if you want. I'm going to come back to here, and I can add a position argument. So I say position equal to, again, top left, top right, bottom left, bottom right. So for me, I usually like just top right, like something in here. And because the layers control only has one argument, so you don't really need the star KWARDS. You can just remove this one and then do the same thing here, but you need just position equal to position. That's it. So what this one is doing is that when user add the layers control, if they specify a position, it will use the position that the user specify. If it doesn't, it's going to use the top right corner. That's it. So now come back here, restart, run this one again, run this one again. And then click again. See? Now you have the layers control in the upper right corner. Exactly what we want it to be. Okay? Nice. So next, how do we actually add this one by default? So the user don't have to run the map.addLayersControl. I want just maybe user, when they created GeoOS demo.map and then display the map, the layer control is already added by default. Anyone? How do we actually add something by default? Where does it go to? Alright, so when it's creating a map, which function is being executed when you are running the map, creating a map? I want to do something without user having to run this line. The layer control is added by default. Right, so if I come back to here, run this one again, the layer control is not there. So how do I add something, load something automatically without basically you do something on behalf of the users, so the users don't have to worry too much about that. Yes?
Set as the default value.
Set is the default value. So where does that go to? Remember? When you create a map, this function is always executed. So underscore init. Whatever you want to do by default, it should something go under here. Right? So think about, I can just simply come to here and just self doc, because when you have those functions, now you can call those functions under yourself. So I can just maybe add layers control. See, those functions now should be available in here. So what we are trying to do here is that when we create a map, you can pass in all kind of parameters. Then we ask to create a map based on IPyLeaflet. Once the map is created, you have doc self. So the self, now you can do anything to that map. So I'm going to by default add the layers control. Control S, come back, restart the kernel. Now take a look. See that? Is it coming up? Yes? Pretty nice. But keep it in mind, you also need to make it flexible. Right now, you basically, no matter what, you add the layers control. But there might be users saying that, okay, I don't like that one. Can you remove it? Or can you provide an option for me to customize it? Or provide a parameter or argument saying that I can turn this one off because when I don't need that. I only have one layers. There's no point of having the layers control button on the upper right. I just don't like that. How do you turn it off? Or how do you provide an option for users to specify whether they want it or not? How do you customize it? Anyone? So here, think about like user can provide unlimited number of keyword arguments in here. Maybe I can add another one called layers control equal to true or layers control equal to false. If this is true, I'm going to add that. If this is false, I'm going to skip that. So rather than run this one, no matter what, you want to have a conditional statements. Allow the user whether to specify or not. Make sense? So here, I can do it this way. Let me show you like what does this mean. Right, so indented. So if there is a keyword argument called layers control that the user specify, I'm going to use the user argument. If it's not there, I'm going to just add it by default. Okay, if the user don't ask for it, I add it. But if the user doesn't want it, I'm going to skip that. So this is what I think this is very important for most of the Python packages or the map class, whatever class. If you want to by default want the user to have flexibility, then you might want to do something like this. So what I'm going to do here is if I say layers control, Okay, pretty intelligent. So if the layers control not in the keyword argument, I'm going to set that one as true. Okay, if the user provide, I'm going to use the user provide value. So once you have this one, then you can do something like this. If yeah, okay, nice. If the keyword arguments blah blah layers control, I'm going to add that one. Otherwise, it's not going to add. So think about here, we're adding these 4 lines. With these 4 lines, then it becomes flexible. So user can pass in an argument to specify whether they want the layers control or not. Make sense? So if the user don't provide anything, I'm going to, because this one is a dictionary, I can modify the value. Basically, I'm adding a dictionary, a layers control to that. And then, if it's true, because if it doesn't exist, I'm going to create one. If it's false, then I'm going to skip this one. So now, Control S, come back to here, restart, clear the output. So run this one again. And by default, right, it's being added. So now I can basically specify, okay, layers control equal to false. Take a look. It's gone. Understand? So it's actually very easy to customize. If you really want to see, for example, here, the keyword arguments, actually, if you don't provide, it will be empty. If I provide, you will have an argument. So sometimes you might need to do debugging. Like, how do I figure out whether what kind of things the user provide, right? Everything is captured in here. So you can print out the keyword arguments before, and then you can provide the keyword arguments later. Print. Just to show you like what this one really means, right? So if the user don't provide anything, so let me restart the kernel and then remove this one. So if the user don't provide, by default, I'm going to use the center and the June. This one should be empty. Okay, make sense? Because the user don't provide anything. But if the user provides something, if the user don't provide, then I'm going to add this one. So let me run this one just to show you what does they mean. See that? So this is before, this is after. Okay, so the user don't provide. I'm just this one is scroll wheel zoom because we added in here, right? So if it doesn't exist, I'm going to assume it's going to be true. And then the layers control, if the user don't specify, I add that one to your dictionary. I add that one to your keyword arguments. But I can certainly specify equal to false. So I can say layers control equal to false. Now take a look. It will be something. Now those two are the same. So if the user provide, it's going to be added as a keyword argument. So you can add as many things they want. It's going to become a lot more flexible with that. So this is about adding a layer control. And let me remove the by default. So similarly, you can add other stuff. For example, full screen control, right? You can add a full screen button here that allows the user to click and then it full screen, right? Just like iPad Leaflet. The full screen button doesn't work here in Visual Studio Code, but if you open in Jupyter Lab or Jupyter Notebook, it should work. Okay, so but I can quickly show you. Do the same thing here. Scroll down, and that one is the layers control. I'm not sure if you can read my mind this time. Probably not. Out of it. What? I don't know. Oh, maybe I already have another script that have something like this, so you can read. Otherwise, this is scary, right? I didn't even like talk, ask him to do something, but the add full screen control. Okay, perfect. Press enter. Oh, nice. Okay, I don't have to really worry about that. So full screen control, position by default top left, and then iPad leave that full screen control, and then add control, right? Pretty much the same as the layers control. So if you want to look at it on the iPad Leaflet website, these are all the controls that have zoom control, scale control, layers control. You can customize to whatever you want, whatever way you want. So full screen control, pretty simple. iPad Leaflet full screen control, and then just add it. So you should have this button somewhere here like this, and then if you click, it should pop up. Okay. So do the same thing here. Now we can, by default, we can add that one to the map. So when it's created, I want to add the full screen control by default. So it'll be very much similar to here. If full screen control, okay, perfect. This one here, it doesn't matter. You just need to use whatever you want to use. It doesn't have to be exactly like what I'm showing up in here. You can have full screen, CTIL, whatever. That's just a keyword argument that you want to provide to the users. And so if that one doesn't exist, I'm going to set that one by default as true. Then if full screen control, and then I add the full screen control like this. So now the full screen control becomes just like the layer control we added earlier. It becomes flexible. So if the by default it's going to add it, but if the user doesn't want that, it can be turned off. Come back to here, restart, rerun. See that? Now we have the full screen button showing up on the map. Again, it doesn't work in Visual Studio Code here. You need to open in a command prompt and then go into Jupyter Lab or Jupyter Notebook, then it should work. Alright, similarly, I can turn it off. If I don't like, I just full screen control equal to false, layers control equal to false. Debug run again, it's gone. Alright, so this makes it really flexible. All the components on the map is customizable. You can turn it off, you can turn it on. It depends on how you want the user to specify that. Questions? You can also add scale control, draw control. You can add those things by default if you want to. Okay, I would leave it up to you how you want to decide your default map going to look like. Next one, how to add base map. Right now, this is the OpenStreetMap. You need to zoom in, otherwise it looks pretty basic. Just the color scheme is very basic. So if you zoom in, you will only gonna see a lot more details. But how can we add some other base map? For example, I want to add some Google base map. I want to add some Esri base map. There are tons of base map out there. So how do I provide the functionality allow the user to specify what kind of maps do they want? Okay. And let me go back to the IPyLeaflet here. You are welcome to use ChatGPT or just Google. For example, how to add a base map, how to add a tile layer, something to the map. So it's actually under the layers. So we go to the layers button, menu, and then tile layers, tile layer. So this is essentially what how IPyLeaflet deal with the base map. Looks a little bit complicated. I will show you a better way to do this so that users can just provide a string and then it will add the base map, just like what I did for IPyLeaflet. If you want, you can just simply copy this one, copy the code, and then come back to here. You can just paste it just to test it out. Okay, take a look. Right. So this is what the base map is. Very flexible. What this one is doing is actually converting the base map to a tile and then add the tile to the map. So this is the so-called tile layer. If you scroll down here, this is basically a class. Just like the map class we created, IPyLeaflet also has one called tile layer class. So the tile layer class is constructed using these parameters: the URL, the zoom level, the bounds, the tile size, the attribution, something like that. These are not really essential. The most critical one is the URL. So all the base map out there on the internet has a URL. So what you need to figure out is what's that URL. Once you have the URL, you can construct a tile layer and then you just add the tile layer to the map. Pretty simple and straightforward. So I'm going to show you how you can actually do that pretty easily. So go back to here, and I'm just going to use this example. So I don't really need to. Let's figure out the example first, and then you can add the function to the map that allow the user to do that. Okay, so here let's say I want to add the Google base map, right? What do we need? We need the URL to the Google base map. Okay, don't just type map.google.com it doesn't work. Okay, that one is not the right one. That URL is not that URL, so it needs to be something standardized. It's called XYZ Thai URL. I'm not sure if you can Google it. Google satellite XYZ tiles. You might be able to find it. Yeah, okay, here. Just Google it. You can also go to LeafMap. It should be there as well. So, right? These are some of the URL. These are the URL. The so-called XYZ Thai layer. So this is more like web map services. So what you need actually is something like this. Oops. For example, I want a hybrid based map. So hybrid based means you have the satellite, but you also have the labels on that. So what you need is this URL. Once you get the UI, you can add the layer. If you're just simply trying to open this one, it will show you that it's invalid. So, but let's copy this one here and then come back to the map. So what we want is maybe just define a URL variable and then just paste this one in. Okay, done. So this is the URL. With the URL, now we can construct a Thai layer, and the Thai layer can be added to the map. So again, if you go back to this example here, right, IPy leaflet.thai layer, and then just passing URL, that should be good to go. So, but you need to import the IPy leaflet Thai layer. So I'm just going to import IPy leaflet, okay, and then I can just construct the Thai layer. So I can just use a variable layer equal to, okay, perfect. Layer equal to IPy leaflet.thai layer. So the Thai layer is constructed based on the URL. Okay, you can give it a name if you want. Now we have this layer. It becomes a Thai layer. With that Thai layer, now we can add that one to the map. So take a look, see what's going to happen. M.add is lowercase layer and then the layer. Okay, so take a look, run. Is it coming? Layer already exists. Let me restart column. Sometimes might be duplicate. Run. And I want the layers control because I want to turn the layer on and off. Okay, this is by default. You get the URL and then construct the Thai layer. Add that. Boom. See that? Now with the layer control. See here? Isn't that nice? So this is the Google satellite based map. This is how you load it into map. But keep in mind, Google based map actually we are kind of using illegally. You need to actually pay an API, but it's the way they have been provided for many years. They never come like trace you down to pay money. It's the URL that you can use in a web app, and then but you might need to have an API, but it's, I don't know, they don't restrict you to use, but technically we are violating the term of service. But I'm showing you, but there are a lot more base map that you are free to use. I will show you more examples there. But specifically for Google, you need to look at the terms of service. Make sure that you don't violate the term of service. But this is how you add a base map. So similarly, let me show you another one. Right? Come here. How about this? I want to add the Google map. So this one is actually the Google map. Okay. Copy. Come back to here. And then I can replace the URL. Okay. So do the same thing. Construct the layer. But this time I can just say Google Maps. Okay, layer, edit, boom. Now you have two layers, Google Map, Google Satellite. Pretty simple, right? Nothing fancy. It's really easy to use. But at least you can give some credits to Google, because lower right corner here on the map, this is called attribution control. Attribution, basically you add some text, label, whatever, to give credits to the data provider. So in here, if you want to, you can certainly do that. So you can just do it this way, the name, and then you can have like attribution, because attribution is an attribute of the Thai layer, because the tile layer, we only use the URL and also the name, but there are a bunch of others. So you're welcome to specify the value if you want. What we are trying to do here is we want to specify this attribution just to give credits to the provider, and then come back here, run this one again. But because Google Map is already there, so you might need to restart, otherwise it might not work. So let me show you here. Add this one, run the map, and then this is the URL. Import ipleaflet, add this one, add this one. Okay. So now lower right corner here, do you see the new attribution added? Google. Alright, pretty simple. So we already figured out the example. So this is usually how I would do that. I don't directly write code into the module yet. I just tested it, figure out some sample examples, and once I get the example works, then I try to reorganize that, make it into the function, so that it's much easier. So the user don't have to go online to do all kind of stuff. And okay, so next, come back to here. Now it's time to add the function, right? So we can just come here, add a new function. DEF, I can say add maybe tile layer or something. Okay. So for this tile layer, I want to provide a couple parameters, right? So definitely you need the URL, because the URL is the most critical one that the user need to provide. And then I can have like default the name, or you can have attribution if you want the user to add it. So I would say maybe self, and then URL, and then maybe the layer name. The layer name is the one going to show up in the layers control. And then attribution maybe. Okay. Perfect. Autocomplete. And since the tile layer has so many other parameters, we can just provide a keyword argument ** KWARGS, but make sure that you passing back into the tile layer. Otherwise, this one is not. If this grayed out, that means it's not passed back to here. So on the comma, and then ** KWARGS. Look at this. Right. So this is essentially that you edit the base map by the user simply just provided URL. They don't right now. They don't need to import ipleaflet. They don't need to create a tile layer. If under the hood, you create a tile layer for them, so that they don't have to like learn all the stuff. Now, if there's just one line of code, they can add the base map. Make sense? So again, restart the kernel, create the output. So here, I can create a map, and then the same URL, right? Instead of import ipleaflet, now I can just m.add tile layer URL name equal to Google Maps, and then if I want, I can provide attribution equal to Google. Run. See that? Perfect. With that, you can extend this one to any base map. As long as you have the URL, you can bring the data in. So there are tons of URL on the internet allows you to pull the data in. So we only have one layer, but you're welcome to add more data layers if you want. So I can add satellite base map, I can add Google Map, I can add terrain base map. It's all going to have a bunch of data layers. So you can add as many data layers as you want. Questions? Next one. How do we make it even better? That the user just provide a name rather than URL, because for them, they still have to figure out where does that actually come from. How do you have to Google? But I can just provide base map equal to hybrid, base map equal to Google Map. Then it's done, but even easier, because you don't have to remember this long URL. So how do you actually customize it so that user can just provide a simple URL and done? A simple name, find a string rather than a long URL. Can we do that? So I would like map.add, maybe add base map, parentheses, base map equal to Google Map, and then you add the Google Map. In that way, I don't have to worry about the URL. Can we do that? Yes? Should be pretty simple. So all I need to do here is actually add another function. So I can say df add base map. Okay, I can have just the name of the base map and whatever parameters you want to provide. So think about here. This is where this is where you want to think about what kind of base map you want to predefine, right? So you want to allow the user to do that, and you can have a couple parameters. I will say here, if let's say if base map equal to, how about this, row maps, ROAD maps. So just like, for example, let's look at this example here, row map, terrain, alter base map, satellite, terrain, hybrid, something. So I can say, for example, equal to hybrid, then I'm going to add a hybrid base map. So the first one is just the row map, so I can just maybe or how about this, maybe the lower, because the user can enter uppercase, lowercase, whatever. I can just use if lowercase, and then you'll be equal to row map. Okay, if this like this, then I can just figure out the URL equal to this one. Make sense? So if the user provides a base map and then just row map, I'm going to get this URL, and you can have the name equal to base map. You don't have to specify. I then just call this one. Oh, sorry, you need to have self at the beginning, self.base map, and then like this. So you'll be self.add tile layer URL, and then so this one you will be going to say name equal to base map. This is just a string, so whatever the user provide, I'm going to do that, and then so just going to pass in this URL. It should add the base map. So in that way, you don't have to worry about other stuff. Okay, Control S. Now let's come back and then let's test it. So restart the kernel, run it. And let's see what happens. So I'm going to add another one here, m.add base map. Okay, so now user don't have to write the wrong URL. I just type the simple string row map. Take a look. Even better, right? Isn't it? So uppercase, lowercase doesn't matter. I can just row map. It should add the same thing, and upper right here, or you actually add double. So it depends on how many times you add, right? So this is just one base map. You can add many others. I can add hybrid. I can add others. So again, I'm going to be just copy the other one here. Hybrid base map. Come back to here. Oops. So else if, okay, satellite. Perfect. I don't know how it figures out, but I'm going to copy this, paste this one just in case. So if this equal to row map, I'm going to add this one. If equal to satellite, I'm going to add a Google satellite base map. Similar, restart kernel, run this one. Okay, so first let's add the row map, and then next let's add the satellite base map. So m.add base map, and then satellite. Boom, done. Right, so now you can pull in data base map from all kind of places. So this is one way you can add a base map. There are many other base map available, hundreds of base maps, and there's a package called XYZ services. You can Google it, but I also put that on the website. So go to resources. There's one here. If you scroll down, XYZ services. So this one actually provide a collection of base maps, and you will have all the URL. I'm going to show you quickly. This one is a little bit more complicated, but it's actually pretty easy to use. So it's a package, and then you just import this one. Then you should be able to get the URL. With this URL, then you can add that base map to the map. So because this package is a dependency of ipyleaflet, so when we install ipyleaflet, this package is already installed, so we can actually directly use it. And what you need to do, I can just simply come here, copy this one, come back to the notebooks. I'm just going to show you how to use that, because there's no point of you going out to collect so many URL, because there are hundreds out there. But this package gives you all access to pretty much all of them. So Control V, okay, and then once you have this one, you can XYZ dot. You can just press the Control space to bring up the help documentation. So you see here, there are local base maps, right? Google Map. Google, I don't think Google is there. Again, it's illegal, so they don't include this one in here. But other base map, you're welcome to use. It's all free. For example, Esri base map, right? And then dot again, Control space again. Oh, it doesn't swipe up. Anyway, so let me see here. Esri dot. I think the wall base map, wall imagery, that one should be available. So if you just type XYZ dot Esri dot wall imagery. Take a look at this one. Remember earlier what we want is a URL. It actually has a URL. So how to actually get access? But because it's a variant, so you don't want to directly use this URL, you actually have to so-called build the URL. So what you need to do actually is this one, dot build URL, and this is the one you really need. So build URL basically means, because each base map under there, they have a bunch of base maps, so they're using the same format. So the variant, basically they're replacing the name within the URL. Otherwise, if you without this one, again, I'm going to show you here. If you look at this URL, right, server online blah 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 services, and then you see this one here, curly brackets variant. This one is not a valid URL. So when you build the URL, it's going to replace this one with here, so that it becomes a real URL. Okay, that's why we use the build URL. So build URL again, right? Now we get access to this URL. With that, we can use the map.add tile layer. Then we should be able to add a base map to that. So pay attention here, right? And let's change this one to available. Okay, so URL equal to this one, and then m.add tile layer, then just passing the URL equal to URL, the name equal to maybe Esri or imagery. Control enter. Take a look. Now we have the Esri base map, and again there are over like 400 base map over there. So this is how you can actually allow the user to add any base map to your map without having to go online to search all kind of URL. Now, see? And this is exactly like in a leaf map or Gmap. Like this is how the base map being added. Okay. So next, I'm going to show you something that makes it a little bit easier for you to add a base map. So think about here, if the user provide raw map and satellite, I'm going to add that. But how about the user provide Esri.wall imagery? Can you add that one, right? So it's kind of similar to what we did in the example earlier. So what we can do is that we're going to utilize this XYZ base map, and come back to here. I'm going to import this one at the beginning here. So if else, and then I'm going to just type else. That means otherwise, if the user provides something else, I'm going to try to find the base map from the XYZ services. If it's there, I'm going to add it. Otherwise, I'm going to show an error saying that the map doesn't exist. Make sense? So what we can do here, because this is potentially going to run into errors, you want to put this one in the try except. Otherwise, most likely the user is going to provide anything. it's not going to work. Okay, so you need to catch the error. So we need to try, and then what we can do here, this one is a little bit tricky. We haven't covered this one yet. So basically we want to convert a string to an object. If that object exists, then it should work. If that object doesn't exist, then it's going to fail. So what I'm just going here, just maybe show you here first, right? Assume the user map dot like add base map, okay? And then like this. Think about here. If you run this one, it doesn't show you any errors because we haven't catched this one yet. Earlier is just if else, and that's it, because it doesn't meet any criteria. So basically this one is just skip. So how to actually convert, for example, from this Esri.word imagery into a tile layer so that we can add it to the map. In Python, there's a function called evaluation, EVAL. So that one can actually convert a string into object. So just type EVAL, okay? Oops. Take a look at this one here. Evaluation basically means you're going to treat that one as like no string. So earlier, if you see, yeah, this is not going to work. But we have this one here. So here, xyz.esi.word imagery. It might be a little bit confusing, right? So think about here. This is basically the Python object, right? But I can have another one here. Do the same thing, xyz. You can like with comma or double quotes or single quote. So look at this too, right? This one is without the quotes. It's just like treated as like an object or variable. This one here have single quotes. So these two actually are very different. Okay, this one is a string. So the evaluation function basically is to evaluate whether this one, when you take off the quotes, will it be valid or not. So right now, if I add another code block here, right, evaluate, and oh, where does it go? Single quotes. Oops. And now let's evaluate this one. It might be a little bit difficult, but I hope it makes sense. This is the real variable without a quote. This is just a string. And I'm trying to evaluate if I take off the quotes, would they be valid or not? If it is invalid, it's going to throw an error. If it's valid, that means right now you see here, it looks good. But if you add something else, for example, blah, 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 oops, like this, see that? It doesn't exist. So that one is not a valid name because you are basically trying to retrieve an object from this XYZ package. If it doesn't exist, you cannot do that. So if it exists, perfect, you can convert that one into an object. Then you can directly access the object. You can get the URL, you can build the URL, you can get that, right? So this is what we're trying to do here, that we use this function to allow the user to add base map to that. So let me come back here quickly. I'm gonna try. So this is exactly how you can do that. I can say, so annoying here. And I can just maybe base map equal to evaluate. Okay. And, oh, perfect. It's pretty intelligent. So it's going to evaluate XYZ dot whatever the user provide. If that one is valid, then I can start building the URL and then add the tile layer to the map. So here, I can just URL equal to the base map dot build URL. Okay. And I can also have the attribution equal to base map dot attribution, and then right, perfect. Yeah, something like this. So with that, except I can raise an error saying that base map not found. So this is what you can do to easily convert the user string input string into a base map object, and then get the URL, get the attribution, and then one back to the map. Make sense? Probably not, but let's try it out. So come back to here, restart. Now take a look. So we're gonna add this one. So if the user provides a raw map, the hybrid, the satellite is going to add a Google map. If the user provides something else, it's going to add that. So now let's see what happens. So m.add base map. Okay. So we're going to use, for example, the Esri wall imagery. Press enter. I hope it works. Boom. See this one? So now the user no longer have to provide. There are a lot more base map available. You want to figure out like what kind of base map available. I can run this one again. I can just show you like what's in there. So with that, you can just type, for example, xyz.keys. Keys means just show you all the top level, all the category. So you have all these base map available, and there should be one called Esri base map somewhere. Or you can just type xyz.esi.keys, right? So these are all the names available for the Esri base map. So if you scroll to the right, there are a couple of those. For example, let's say I want the National Geography base map. So Control C, come back to here, add base map. So it'll be ESI, whatever, National Geography base map. Run. See that? Isn't it nice? Now the user don't have to provide long URL. You can do whatever you want. And there will be other ones. So how about this? For example, the Carto DB also has a lot of base maps, right? Position, blah blah blah. Some of those minor work, I'm not exactly sure. How about this one? The dark matter, right? They say I want to add this one. So the user, you need to basically different categories. So it'll be Carto DB and then the dark matter. Okay, run this one. How nice! And this is how you can add a base map. You can add as many as you want. You can create another function to list all the base map if you want to, but I don't want to make it too complicated. At least I show you how you can pull some base map and then load it on the map. Questions? Well, it's 20 minutes, so I'm going to go to the next one, how to add vector data. Okay, so play with this one. You will need to add something similar like this to your package. Okay, I've already shown example page, you just copy paste, but at least you can understand, play with that, see how you can actually manipulate, and show some examples on your notebook that you can add a variety of base map. And this is open up a whole lot more potential. You can pull data layers from anywhere. As long as they provide the XYZ type URL, you should be able to load it onto the map. Okay. Next one, vector data. Okay. So vector data have a lot of formats, right? Most common one will be Shapefile, GeoJSON, GeoPackage, KML. There are a bunch of others. But for this lecture, I'm just going to do two simple ones: Shapefiles and GeoJSON, right? So if you can do that, it's a good start. But you can use GeoPandas to handle any vector data. So, or even GeoDatabase, you can also do that. It's very flexible. So, the first example I'll show you is actually GeoJSON. If you go to iPad Leaflet, and on the left side here, you will see the GeoJSON layer. And this example that shows you how to load the data layer to the map. Looks quite complicated. And I'm going to show you how to do that with one line of code, right? It's very flexible, you can customize, but most of the time users don't have to like go through so many steps. I just want maybe have a function that users just give me the URL or the file path to the GeoJSON, the vector data, or to the Shapefile, done. And then I take care of the rest. But if you want, you can certainly just copy this one. You can go back to your notebook and then try to customize that. Essentially what we need is this one here. So the GeoJSON is a class, and within there, this is the most important of the data. So the data actually is a dictionary. So the dictionary is basically a GeoJSON. For those of you who are not familiar with GeoJSON, it's basically just a dictionary string. And I put a URL here on our website. Useful website, geojson.io. So you can just take a look, open this website, just take a look at like what does the GeoJSON look like. Okay, right now we don't have anything here, so it's actually, if you save the GeoJSON to a computer, it's a plain txt file. If you open it, you're going to see the contents inside. So for this one, I can add a couple stuff. I can add a point. So here, if I click this one, see the GeoJSON to the right. So if I click, it's going to add it. So GeoJSON is a so-called feature collection. So you can think about it's a swap file. You have a bunch of rows. Each row is a feature. So it's going to have a bunch of features, and the square brackets, right, in Python is a list. So if I add more, for example, click another one and another one, right, it's going to put within the list. So this is essentially what the GeoJSON look like. You can use this simple website to create all kinds of GeoJSON, and then you can just click save GeoJSON, and you can save this one to a computer. Once you have that, you can just open any TXT editor. So I'm gonna click this one here. Oops. And then you can drag and open. Look like this. Exactly what looks like on the website. So it's just a simple TXT, but this is a vector data file. And I'm going to show you how you can actually load this one to the map. One line of code. So like pretty simple. But maybe the point is too simple. Let me create something like polygon. Do you want to recover the map? No. So how about this? Let me draw a rectangle or something. Like this. And maybe another one. You may need to double click to finish. How about this? I just have two simple swap files, but I can do that for any vector data. You can convert a swap file to GeoJSON. I'm going to show you to do that shortly. But this is, for example, this is simple vector data that you have. How to actually load that one in Jupyter Notebook? How do I add this one to the map? Okay, so save this one, and then I'm going to put it under my GeoJSON documentation folder, examples. I can add another folder here called data. And we can just choose a name, maybe call sample.geojson. Okay, so I have this file. Now let's think about how we actually load that one to the map. So if you go back to this example, IPyLeaflet in here, everything that you in IPyLeaflet is either a layer or is a control. So if it's a layer, you construct the layer based on that layer class, right? If you remember earlier, we have the type layer, we have the GeoJSON layer. These are all the data layer available, right? So only two of those. And for this GeoJSON, we're just going to use this one. So it's IPyLeaflet.geojson. Then you pass in the data. So the data is a dictionary. So you need to read the data from the file, convert that one to a dictionary. And then we select dictionary, you just pass in, then you should be able to create this one. So I'm going to show you how to do that quickly. But if you want to convert it to a JSON, you need to use the JSON library. So import JSON, and then it'll be like this. We open the file and then load the file into the JSON. So what this one is doing basically is going to open your GeoJSON file, read all the text, convert it one to a Python dictionary. Then you can use the dictionary to construct a GeoJSON layer and then add the data layer to the map. Make sense? Just like you're opening a file using ArcGIS, it's going to open the file, you're going to read all the content, and then it's going to convert the content to whatever format that's within that software, and then display on the map. So let's come back to here, just to quickly show you like what we should be doing. I'm going to add a function called def add GeoJSON, something like that. Oh, it's pretty intelligent, but this is probably not enough. So ipylib.geojson and then data equal to data. That one is a dictionary. I want the user to be able to provide a file path. If there's a file path, then I need to read the file. So we need to add a couple more steps before we can get there. And so what you can do is to figure out whether the user provide a dictionary or the user provide a file path. A dictionary is a dictionary. A file path is just a string. What we can do here is to figure out. So if is instance basically figure out the file path, the data type. Okay, nice, pretty intelligent. So if this is a str, if this is a string, I'm going to import JSON, then I'm going to read the file and then load this one into a JSON. And pretty much I think this is it. It should be able to add the data layer to the map without you worrying about how to load the JSON. So it'll be just one line of code. And let's test it. So come back to here, restart the kernel, clear all the outputs, and then run this one. So next one is just providing the file path to GeoJSON, and then it should be able to load the GeoJSON on the map. Because the ipylib only accept the dictionary, you can write a function to convert the file path into a GeoJSON, the dictionary under the hood. So what we're going to do here, you'll be m.add. Let me see here. Did I miss something? No, I think we are good. So add GeoJSON. Right. Now we just provide the file path, whatever file path to your GeoJSON. So I'm going to provide data, and then is it somewhere here? Sample data. Is it empty? GeoJSON docs examples. Oh, it's not in there. So I'm going to drag this file into the data folder. Now come back to here. It should work now. See that? Now, how nice. Now you know how to actually add GeoJSON. It's just a simple file path. I can also provide dictionary if I want to. So if there's a dictionary, it can also add that nicely. So here, also by default, it doesn't have it's empty. The layer control, you can probably add a name parameters. So that by default, it's going to add a layer name. So I can come back to here. Because it's a layer, so it doesn't exist, or I can provide maybe, let's say name equal to, you can, if the user doesn't provide by default, you just add this one. So I can say GeoJSON, for example. It's a layer name showing up in the layer control. And do the same thing here. Name equal to name. So in that way, rather than empty, you have the layer name showing up here. So again, come back to here, restart, clear. 1, 1, 1. Okay, so see that? Now I have this one. I can certainly also customize the layer. You can add multiple times. So this time I can say equal name equal to maybe countries, whatever. Run again. They're the same, but you can change the layer name. Questions? Easy, right? Well, everything is one line of code. And later on, you can even like interface, no code. You can provide interface. We covered it in a week or two. How to design the user interface. So how you add some button to the map. So user just click, provide the file, select the file, and then boom, it's done there. So this is how you can lower the barrier and makes it so much easier for user to use a package, right? So it can be GeoJSON, it can be vector, it can be pretty much any data you want. Okay. So next, let's add another one. Make it even better. How about add a thread file, right? So you can actually convert a thread file to GeoJSON, because ipylib they only accept GeoJSON, but you can pretty much convert any vector data type to a GeoJSON. Then you should be able to add the vector data indirectly to the map. Okay, so how about this? df add maybe SHP. Okay, so do the same thing, self. Then you need to provide the data. Okay, how nice. I don't have to write it. But you need GeoPandas. Okay. You need to add this one to your requirement.txt, because earlier we don't use anything outside the built-in library or other dependency of the IPyLeaflet. The GeoPandas is not a dependency of IPyLeaflet or Phonium, so you will have to add this one to your package. Otherwise, user will not be able to use this one. You will throw an error. So if you add any external libraries, simply just copy the name and then go to requirements.txt. Here, paste, Control Enter. So in that way, the package will be installed when the user install your package, right? So come back here. Right now, you will see it's yellow line here, probably because my library has not installed the package yet. So I can quickly just show you how I do that, right? Anytime if you add anything additional, you need to restart the kernel. So I'm just contact activate GOS. Then you can just pip install, contact install, whatever. So GeoPandas used to be very difficult to install on Windows. Now seems much easier, so it should work just fine. You can just install it. If you run into errors, if a package is not going to install smoothly on multiple platforms, you probably don't want to add it into the requirement.txt, because your package will fail to build and the user will not be able to install your package because something goes wrong somewhere in the middle. I hope it works fine. Okay, now you might need to close it and restart. Okay, we only have 5 minutes. I'm going to quickly show you how you can get this one work. Okay, and reopen it. And now the curly line should be gone. Okay, it's gone now. Import GeoPandas as GPD, and then so GeoPandas can actually read a bunch of like different data format. Once you have the geodata frame, you can convert that one to a GeoJSON, and then we just call the GeoJSON, right? Perfect. Just adding a couple more lines code. Now you can have this one. You can add any vector data, any shape file. So, of course, you need to find some vector data. I don't have anything here right now on my computer, but I can quickly download a sample vector data, and then we can load that one to the map, just to show you what it looks like. So I'm going to go to my examples on this map. Examples. I believe I have some data here. Data. Okay, and what is country.zip file? So I have a country.zip file. Within there, you actually have some vector data in there. So I'm just going to download this one to my computer. So data examples here, and yeah, it's downloaded. So you're welcome to open it and unzip it. Right. So this should be the data in here. I can just copy, come back to here. And one thing I would like you to know is actually GeoPandas can read a zip file. So you don't have to unzip it. You can directly pass in the zip file. So let's test it, see what happened. Come back to here and then open the notebook. Now let's test it, see if we can add a swap file into the map. Just one line of code without having to convert the swap file to GeoJSON explicitly. I just use the map.add SSP. Oops, what happened? Try. Did I do anything? It's weird. I don't know. Now it works, right? So let's test it how we can add a swap file. So you'll be here. Let's add a couple lines, and then m.add SSP, right? Now just simply passing the URL. I just want to pass the relative URL. So data countries dot zip file, and then the name equal to countries. I'm not sure if it works or not. Oops, what happened? Blah blah. Oh, the file doesn't exist. You might need to pass in the full URL. So how about this? Let's do this. TRIES. Maybe the shape file. If it doesn't work, try this one. Oops. Data. Did I miss something? Countries. COU. Yeah, OUN. Okay, there's a typo in there. No wonder. Okay. No such directory. Oh, it's convert to a JSON string, so we actually have to convert that one back into a dictionary, because by default it's just to JSON is just a string. But I think you can do it something like this. You'll be geodev dot geo interface. This one is better. This one directly converted one to a dictionary, so that you don't have to, because otherwise there's a string, you need to convert a string back to a dictionary. So this one should work now. So restart, clear. I hope it works. If it works, then you can actually pretty much deal with any vector data. KML. Oh, you see? How nice. Right, now I have the vector data loaded. Again, let's try it with the zip file. So if you have the vector data, you don't actually have to unzip it. So this time I can say countries.zip. It should work as well. See that? How about that, right? Now you know how to load the vector data. And this is just the simple one. It's using the default stuff. You can customize the style, you can customize the color. There are a bunch of things you can customize. So if you really want, you can look at the IPyLib example here. You can customize the style, hover the style, something like that. So I can maybe just, how about this? Try this one. Copy. And then, but you need to make sure that in your package you have the function to do that. So because we have the keyword arguments here, you can accept anything. So now if I come back to this one, I can actually add a style. So style equal to this one, right? And then within your function here, you just passing the style equal to style, and take a look. Isn't it working? Style equal to style. Yeah, we're running out of time, but yeah, you can try it out. It should work. So you can customize style, the hover style, and so for the left 7, you are doing something very much similar like this. Provide some examples, but one addition I want you to be able to do is actually to also set the file path as a HTTP URL. So the user can just pass in the HTTP URL. Your program should also be able to add that one to the map. So user don't have to download data to their local computer. Just passing the URL and then add the data. So that's one addition that I want you to figure out how actually you get the data from the internet. If you're using GeoPandas, it's just passing URL, it can read the file. So your program should be able to handle that properly. Okay, so that's all for today. I will see you next week.